Hello everyone, in this video I am going to teach you the discriminant of quadratic equation. Let's begin by describing or defining what is a discriminant. The discriminant is basically a number, okay? It will reveal or it reveals what type of roots the quadratic equation has. Now when we talked about roots, it means these are the values of x that will make a quadratic equation correct. Now, the number d equals b squared minus 4ac. So that's the formula for the discriminant determined from the coefficients of the equation ax squared plus bx plus c is equal to 0. Okay, so based from this slide, we can learn that number one, discriminant is a number. And it will tell you, without solving the quadratic equation, it will tell you what type of roots the quadratic equation has. So when we say what type of roots, I classified it into four different things. The first one is if your d is less than 0, that means it's a negative number. Then the nature of the roots will be two imaginary roots, meaning without even solving a quadratic equation, okay? If based from the computation of the discriminant, which is equal to a negative number that's less than 0, then you will be having two imaginary roots. Other than that, every roots will be real numbers, okay? But I classified those real numbers into three. The first one is if d is exactly equal to 0, then you will be having two identical rational roots. The next possibility is that if your d is greater than 0, but it's not a perfect square number, then you will be having two distinct irrational roots. The last one is if your d is greater than 0, but it's a perfect square number, then you will be having two distinct rational roots. Okay? So here, we can classify the roots into two, like imaginary and real roots. Okay, now out of those three real roots, we can still classify them into three. Like if d is equal to 0, then you will be having two identical rational roots. If d is greater than 0 but it's not a perfect square number, it's going to be irrational. So solving that kind of quadratic equation will be different, like a different approach, like quadratic formula. And if d is greater than 0, but it's a positive perfect square number, then you will be having two distinct rational roots. Okay? I know there's a lot of terms you need to understand here, but let's go straight to the uh, what's this? Review part of the table. So if the discriminant of quadratic function or quadratic equation is equal to 0, then it has, what's the answer? Equal to 0. That's right, you're going to have two identical rational roots. If the discriminant of quadratic function is a negative number, then it has, that's right, two imaginary roots. If the discriminant of quadratic function is 16, now 16 is positive, but is it a perfect square number? Is there a square root of 16? Yes, there is, and that's 4, right? And negative 4. That means the answer for that is, I will give you a chance. That's right, it's letter D, two distinct rational roots. And then the last one is if it's 20, 20 is positive, but it's, yes, it's not a perfect square number because if you take the square root of 20, it's going to be in decimal form. Therefore, the answer for that is letter C. You're going to have, or the quadratic equation has two distinct irrational roots. Okay? So, let's go straight to the finding the discriminant of quadratic equation. Let's have this one. So based from the formula, the discriminant is b squared minus 4ac. So you need to identify a, b, and c. A is just the numerical coefficient of the x squared term or the leading term. So what is that number beside x squared? What is the numerical coefficient of x squared? That's right, it's 1. We don't normally write 1 there, But how many x squared do you see? It's just one, right? Okay. So b, what is that? B is the numerical coefficient of the x term, the term with x, and that's 6 here. Okay, it's number 6. And C stands for the constant. So here it's 9. So now that we have A, B, and C, all we need to do is just plug them in the formula. Oh, I did not plug. I did not replace B by 6, but 6 square minus 4 times 1 times C. 6 square is 36. Now after that, you just need to count the number of minus signs. There are 3 possibilities. If you see 1, like in this case, or if you see 3 minus signs, then you put minus. Okay? If you see 2 minus signs, then you put plus. So here we only have 1, so I put 1, or I put the negative sign, and then multiply 4 times 1 times 9, that's 36 also. 36 minus 36 is equal to 0. So what does it mean? The discriminant is equal to 0. If we solve this, we will be having roots that are identical. Okay? That's another lesson, like finding the roots. Okay? But so here, there are 2 identical rational roots. Now, in other books, they will not say this. They will say you're going to have, or the quadratic equation has 2 real roots, simple as that. Now, just to give you a better understanding of the kind of roots that this quadratic equation has, they are identical. Okay, the same. Okay, 2 identical rational roots. There you go. Let's go to the next one. Okay, so that's the formula. A is the numerical coefficient of the leading term, or the x squared term. That's 5. B is the term with x, and obviously we can't see a term here with x. X squared is different from x, so that means there's no b. That means b is 0. C is the constant. You gotta consider the sign of that, so that's negative 2. Plug them in the formula. A5. C is negative 2. 0 squared, that's 0. And then, like what I said earlier, count the number of minus signs or negative signs. So here we can see 2 of them. So I will put plus. Then multiply 4 times 5 is 20. Times 2 is equal to 40. That's 40. So it's positive, right? But is there a square root of 40? I mean, is the square root of 40 an integer? Okay, that's right. It's in decimal form. So therefore, you're going to have 2 distinct irrational, or this quadratic equation has 2 distinct irrational roots. Okay, let's go to the next one. Again, I will write the formula here. Identify A, B, and C. A is the numerical coefficient of the leading term, or the x squared term, that's 1. B is the numerical coefficient of the x term, that's negative 9 here. And C is the numerical coefficient, oh no, C is the constant. There's no constant here. No, there is. That's 0. There you go. Okay, so what's the next step? Plug them in the formula. Negative 9 squared minus 4 times 1 times 0 is 81. There's only 1 minus sign. That's 0, right? 81. Is 81 a perfect square number? Yes, it's a perfect square number. Therefore, you're going to have, or this quadratic equation has 2 distinct rational roots. There you go. Okay, let's go to the next example. Okay, so here, identify A, that's -3. B is -5, and our C is -2. So B squared, that's -5 squared, minus 4 times -3 times -2. Okay, just plug them in the formula. What is B squared? That's 25. Count the number of minus signs. I said earlier, if you see 1 or 3, you put minus. Here, you can see 3 of them, so that's minus. And multiply the numbers. 4 times 3 times 2. What is that? 4 times 3 is 12, times 2 is 24. 24 minus 24 is 25 minus 24 is equal to 1. Is that right? It's 1? Yes, that's right. So that means we will be having, or this quadratic equation has two distinct rational roots, because 1 is a perfect square number. Okay, that's right. Okay, let's go to I will just give you another examples. I think 3. There's a possibility that you might encounter this kind of problem that involves in discriminant. Okay, that involves discriminant. So here, find the value of a in ax squared minus 3x plus 1 if the discriminant is 1. So what's missing here is the numerical coefficient of the leading term, right? So a, we don't know that. B, that's -3, and C is 1, and obviously the discriminant is 1 also. Just plug them in the formula. So this is 1, -3 squared minus 4 times A times C, which is 1. So 1, 9 minus 4A. That's right. Next step is subtract 9 on both sides. It's -8, -4A. Next step is divided by -4. So A is equal to +2. So that's 2x squared minus 3x plus 1, right? Okay, second to the last example, what if B is missing? So A is 1 here, B is missing, C is 5, and D is equal to -4. Use the formula to solve for the unknown. We have -4. We don't know B. A is 1, and C is 5. Okay. So this is -4. This is B squared. Count the number of minus signs or negative sign. We see only 1. This is 20. And then the next step is plus 20 on both sides. This is 16. Okay. What's the next step there? What do you think? We want that exponent 2 to be eradicated, right? So how are we going to do that? That's right. We will square both sides. So B can be positive -4. Okay. Let's go to the last example. So this time what's missing is C. Our A is -4, our B is 5, and we don't know C. We know the discriminant, and that is 57. So D equals B squared minus 4AC. D is 57, B is 5. Okay, -4 is our A, and we don't know C. So this is 57 equals 25. Count the number of minus signs. You see 2 of them, so that means plus 16C. Next is -25, -25. Cross that out. 57 minus 25 is 32 equals 16C. The last step is, of course, divided by 16 on both sides. So our C is, there you go, positive 2. Okay, so that's it. It's all about the discriminant. Thank you for watching.